in this case, now what we will do, we will change our model. So we will be using decision tree regression. Before we do that, you all should be clear about the steps. You should be clear about the problem statement. You should gather the data, do the pre-processing, do the train test split, train the model, test the model for its accuracy, overfitting, underfitting, bias, variance, and also you need to check the error, RMSC, MSC. And if everything is good, we need to deploy the model. So what we are doing, first we are reading this data, insurance data. We will be doing pre-processing like encoding, missing value imputation, data standardization, all those things as we already did last time. So this is our clean data. We will remove these columns, the gender column, smoker column, region column, and we will finally have our clean data. So yeah, so guys, this is our final clean data. But what we are going to do now, we will be doing the train test split as we already discussed earlier, 70-30%, which is also fine. Now, before we can start the machine learning part, the actual modeling part, our data is ready in the terms of test X, test Y, train X, train Y. But this is where the model phase starts. So what we are doing from sklearn.tree, we are importing decision tree regression. So first of all, we are using decision tree model, and that's to the regression model. Okay. So it comes from the sklearn's tree module. Okay. Similar to this, you have decision tree classifier also. So as I told you in the starting, that decision tree can be used for regression also. It can be used for classification also. But here we are going to do regression. So I'm removing this. So within sklearn, we have a tree module which contains all the tree, whether it's the decision tree regression or classifier. Now, when you have to create a decision tree model, guys, what are some hyperparameters here? So if you don't give any hyperparameter, it is also fine. In that case, what will happen? This model will go through the training phase. So what I have done, I have created a decision tree regression and I have simply trained it on the train X and train Y. Now during this phase, what is happening, guys? This tree will keep growing. Let's see if I run this. This training phase is done. This decision tree model is built. But if I try to get the depth of this tree, so it is 18 depth. Okay, it's 18 depth, which is too deep. But I don't want a tree of such high depth. So I can start these stopping criteria, right? To stop tree from growing. So first of them is max depth. I will say, hey, put a max depth of 5. My tree should not be deeper than 5 layer or 5 level. If I do that and get the depth of the tree, so from this regressor object, once it is fitted on this fitted model, I am running get depth function to get the depth of the tree, which is 5, right? So this is one of the stopping criteria. This tree is built. But now what is important? In decision tree regressor, once our training phase is done, we need to plot the tree and see how it looks like, which columns it used at which level for splitting, correct? So for that, we have certain libraries. We will be going into them. But before we go into that, you can see here the regressors feature importance. So from this decision tree model, which is 5 layer deep, I want to see which all features contributed into the splitting of this tree. So by using this feature importance, I can check the importance of all the features that were part of my data. And here I can get the name of the feature. So these were the features, guys, right? Now, if you look at the feature importance, which feature gave you the best importance, which is this. So that means this feature is most important feature in this particular tree. So whatever decisions we are making, this feature is dominating with 70% importance. And you see other features, they are less important. Some features are very, very less important. They may or may not be part of the tree. So now, once you train the decision tree, guys, what that means is your tree is built. But never leave the tree to grow infinitely. You should not leave it to the tree, rather you set the depth. And then you should also check which features are playing what importance. But now the next important thing is plotting the tree. Like in linear regression, we were looking at the values of intercepts and coefficients and try to create that equation. Here, what is important is to plot the tree. So to plot the tree within sklearn, there was this tree module, right? If you look above, within sklearn, there was this tree module. So this tree module gives us a function to plot the trees, and that is known as plot tree. So from the tree module, we will have the plot tree. We will pass our train model here, and we will pass the name of our features, all the features. From this variable, we will get our features. And when I run this, it will take slight time, but then it will plot the tree. See, so this is how the tree is plotted. This tree may not be that good in visualization, so I will plot it in a better way. But if you see, there is a root node where there must be some feature, so we need to check which feature was there. Then there is a feature here, there is a feature here. These two may be same feature, may not be. Then at this layer also we have certain splits. So this tree is growing, right? So here it is like depth 1, depth 2, depth 3, depth 4, depth 5. So after the root node, if we keep going down, this is the depth first. So root node is at the depth 0, you can say. So depth 0, depth 1, 2, 3, 4, 5. So 5 level deep tree it is, right? And one more important thing that you should know is that if a feature is already part of split at a particular level, it does not mean that it cannot take part in the split again. Means that same feature can be a part of the split again also, guys, based on the calculations. It can be there again in the tree. So don't think that if a tree has used a particular feature already, that feature is no more eligible for split. I have seen the case, let's say age less than 40 was here, but here again age was there and less than 20. So first, based on age less than 40, you came here, but now even the data was showing a pattern that if age less than 20, then there is a slightly different behavior, and greater than 20 but less than 40 has a slightly different behavior. So these thresholds will change, but the same feature can still be leveraged at different depths also. That is something important. Now, there are some explanations being shown here, right? Now, what are these? Very, very important. These explanations are important. This is showing you the very first column which is used for splitting is smoker column. And the value is 0.5. We will talk about this in detail, but the first column used for splitting was smoker, and then so on. Then there is age and children. But let's see how that is happening. So instead of sklearn's plot tree, we have better way of plotting the tree, and that comes from a library known as GraphViz. So there is a graph visualization package. We have to separately install these packages, graph visualizations. But using this graph visualization, I can again pass my model object and get an output file. Okay, this is one of the way, but in some cases even that may not work. So what I am doing here, from the graph visualization package, so we can do pip install of graph visualization. Here there is a source class. Within this source class, I am passing that same object, the export GraphViz. So what this means, guys, let me tell you. This export GraphViz function, it converts the tree information into a dot programming language, DOT, and that is leveraged by this graph visualization package to plot the tree. And output file here is none. That means I am plotting it on the screen. So this chart is quite good. Okay. But I am not interested to plot the graph on the screen. So what I am doing, I am taking a format of PNG and rendering it into a output file, D3 render. So what I am doing here, I am exporting the above graph into a file on my local. And from that local, this is the file that got exported. So let me explain you this quickly. So now if you see here, it will clear all your doubts that from that training data, this tree is built. And if you look at this tree, this is the root node. At the root node, the column you are using for splitting is smoker and the value is 0.5. So if the value is less than 0.5 means non-smoker. If value is greater than 0.5 goes towards smoker, right? Because encoded value was between 0 and 1. So going here means non-smoker, going here is smoker. Further, if you look at the samples 935, total 935 records were there in my data set. Now out of 935, you will see 744 came here, 191 came here based on this split. And further, here the split is happening on BMI and here the split is happening on age. So here the split criteria at the child is different, right? So if I show you, this is how this tree looks like, guys.